Download this code from codegive.com, link in the description below. Handling exceptions in asynchronous programming, particularly with async and await in C, is crucial for building robust applications. Here's a detailed tutorial on how to handle exceptions correctly with examples. Understanding async and await. In C, the async modifier is used to indicate that a method is asynchronous, while the await keyword is used to pause the execution of the method until the awaited task completes. When an exception occurs in an asynchronous method, it is captured and stored in the return task. This exception can be observed when you await that task. Exception handling in asynchronous methods. 1. Using try-catch blocks. The most common way to handle exceptions in asynchronous methods is by using try-catch blocks. Just like in synchronous code, you can wrap the code that might throw exceptions in a try block and handle the exceptions in the catch block. 2. Observing exceptions. If you do not await a task, exceptions thrown will not be observed until the task is awaited or the task is otherwise accessed. 3. Handling exceptions globally. In certain applications, such as ASP.NET Core, you can handle exceptions globally using middleware. Example code. Here's a simple console application demonstrating how to handle exceptions in asynchronous methods. Sharp. Using system. Using system.net.http. Using system.threading.tasks. Class program. Static async task main, string args. Try. Await fetched data async, https://api.github.com/users/octocat. Catch, exception X. Console.write_an error occurred, ex message. Static async task fetched data async, string URL. Using HTTP client equals new HTTP client. Client.default request headers.user agent.try parse add request / required for GitHub API. / this line may throw an exception if the URL is invalid or the request fails. var response equals await client.getAsync URL. Response.ensure success status code / will throw if the status code is not 200 to 299. String data equals await response.content.read as string async. Console.write_an data. Explanation of the code. 1. HTTP client. We use HTTP client to make asynchronous HTTP requests. It's important to ensure that it is properly disposed of, which is why we use a using statement. 2. Reading the response, we use await client.getAsync URL to send the request and wait for the response. 3. Exception handling. The try-catch block in the main method will catch any exceptions thrown by fetched data async, including those thrown when fetching the data or when the response is unsuccessful. 4. Ensure success status code. This method will throw an exception if the HTTP response indicates a failure, status code 4xx or 5xx. Best practices. 1. Always await your asynchronous methods unless you have a specific reason not to. This ensures exceptions are properly propagated. 2. Log exceptions. Consider logging exceptions to help with debugging. You can use logging frameworks like nlog or serolog. 3. Global exception handling. In web applications, consider implementing global exception handling to catch unhandled exceptions and provide a user-friendly error message or logging mechanism. 4. Cancellation tokens. Use cancellation tokens to allow cancellation of asynchronous operations, which can also help manage exceptions. Conclusion. Handling exceptions in asynchronous methods in C is straightforward but requires attention to detail. By using try-catch blocks and understanding how exceptions propagate through tasks, you can create resilient applications that handle errors gracefully. Always ensure you await tasks to observe exceptions properly, and consider global exception handling strategies in larger applications. Handling exceptions in asynchronous code using async and await in C is crucial for building robust applications. This tutorial will walk you through the best practices for handling exceptions in asynchronous methods, along with a code example to illustrate the concepts. What is async and await? In C, the async and await keywords enable asynchronous programming, allowing you to perform tasks without blocking the main thread. This is particularly useful in applications with user interfaces, where you want to keep the UI responsive while performing time-consuming operations. Exception handling in asynchronous methods. When working with asynchronous methods, exceptions can be handled in a few ways, but there are some best practices to follow. 1. Use try-catch in the async method. You can wrap your await calls in a try-catch block to catch exceptions thrown by the awaited task. 2. Handle exceptions in the calling method. If you do not catch the exception in the asynchronous method, you can handle it in the calling method. 3. Task.exception property. If you use task directly, without async/await, you can check the exception property of the task once it has completed. 4. Global exception handling. For unhandled exceptions in asynchronous methods, consider using global exception handling strategies, like handling in app-domain.unhandled exception or using middleware in ASP.NET Core applications. Example code. Here's an example demonstrating how to handle exceptions correctly in an async method. Sharp. Using system. Using system.net.http. Using system.threading.tasks. Class program. Private static read-only HTTP client equals new HTTP client. Static async task main, string args. Try. String result equals await fetched data async, http://example.com. Console.read result. Catch, exception X. Console.read $, an error occurred in main, EX message. Static async task string fetched data async, string URL. Try. / simulating an asynchronous HTTP request. HTTP response message response equals await HTTP client.getAsync, URL. Response.ensure success status code, / throws an exception if the status code is not 2xx. String data equals await response.content.read as string async. Return data. Catch, HTTP request exception X. / handle specific exceptions here. Console.read $request error, EX message. Throw, / rethrow the exception to let the caller know. Catch, exception X. / handle unexpected exceptions. Console.read $unexpected error, EX message. Throw, / rethrow the exception to let the caller know. Explanation of the example. 1. Main method. This is the entry point of the application. It calls the fetched data async method and wraps it in a try-catch block to handle any exceptions that may bubble up. 2. Fetched data async method. This method is responsible for making an HTTP request. It has its own try-catch block. It first attempts to fetch data from the provided URL. If an HTTP request exception occurs, for example, if the URL is unreachable, it logs the error and rethrows the exception. A generic exception catch block is also included to handle any other unexpected exceptions, logging the error and rethrowing it. 3. Rethrowing exceptions. By rethrowing exceptions, you allow the calling method to handle them appropriately, maintaining a clear flow of error handling. Best practices. Avoid silent failures. Always log exceptions or notify the user rather than letting them go unnoticed. Use specific exception types. Catch specific exceptions before catching general ones. This allows you to handle different errors in a more granular way. Consider cancellation. If your async method might take a long time, consider using cancellation token to allow for cancellation of the operation. Global exception handling. For larger applications, consider implementing global exception handling to catch unhandled exceptions and log them or show user-friendly messages. Conclusion. Handling exceptions in asynchronous C code is essential for creating reliable applications. By following best practices and using structured error handling with try-catch, you can ensure that your application responds gracefully to errors, making it easier to maintain and debug. Always remember to test your error handling paths to ensure they work as expected.